I'm kind of a big deal when it comes to the Nobel Prize, at least in my own house. I've written 2 books with the words Nobel Prize in the title. The first one, Losing the Nobel Prize, was about my memoir as a young scientist trying to aspire to the greatest accolade in the scientific world. The second comes from my interviews on this very channel with 9 Nobel laureates about their wisdom, not just their knowledge.
It's useful to us in getting into sync with the world, in understanding it and harmonizing with it and being able to cope with it.
And today we're talking about a scientist who had tons and tons of knowledge, but relatively little wisdom. And I call it the worst Nobel Prize ever. There have been several controversial Nobel Prizes. Some say the worst Nobel Prize ever was actually the one given for the lobotomy.
They kept being wrong sometimes.
We're not going to talk about that on this channel. We like to preserve our brains here. True as that may be, there have been actual blunder Nobel Prizes, real bloopers when you think about Gustave Dalén, shown here, who won the Nobel Prize in 1912 for his invention of gas accumulators for use in lighthouses and buoys. Now, who among us doesn't use a lighthouse to get around and navigate their way through life? I know I sure do. Forget that newfangled GPS system, as silly as that Nobel Prize was. And actually, it maybe was of interest back in 1912 or so. However, I remind you, that was just 7 years after Albert Einstein invented the special theory of relativity, the photoelectric effect, Brownian motion, and many other things, for which he wouldn't win a Nobel Prize for another 17 years. He won the 1921 Nobel Prize. But Gustave Dalén got his Nobel Prize a decade before good old Albert. Why is that? Well, for one reason, there was some anti-Semitism with the Nobel Prize Selection Committee. And that's plagued the Nobel Prize for over 100 years. It's gotten better, and there have been a lot of Jewish Nobel Prize winners to date. But there's still possible discrimination and issues with the Nobel Prize that almost every one of the Nobel Prize winners that I've interviewed has admitted to, that the Nobel Prize needs reform, some of which was included in my first book, Losing the Nobel Prize. Now, let's turn to Haber's Nobel Prize. Who was Fritz Haber? What did he do? He's been called the man that killed millions but saved billions. What's a few million people when you save a few billion people? Is that really true? Would the world have actually played out differently if Fritz didn't invent the process that we're about to explore? Who knows? It's called counterfactual history. It's not really that interesting to speculate on. But I assume, like most scientific discoveries, it would have been discovered eventually. And perhaps without his immoral and anti-wisdom type behavior. Now, I've done a video on this channel called Knowledge is Not Equal to Wisdom. And I've also done a video at Prager University called Follow the Science, where I get into some of these same issues. Science has to be first and always about pursuing knowledge. We have a tendency to conflate knowledge with wisdom. When someone's incredibly smart, we think that they're also quite wise. There's almost no correlation between them. Fritz Haber was a chemist, and he was a German Jewish chemist, and that's important for reasons you'll see soon. He was the co-inventor, along with Bosch, of the so-called Haber-Bosch process. And it's that same Bosch that later went on to create things in the German industrial complex, operating from the early to the middle of the 20th century. What is the Haber-Bosch process? Well, you benefited from it earlier today when you had breakfast. You see, their discovery led to the process of fertilizer production that we enjoy in almost all of the food that we eat. It's one of the most important inventions or discoveries in modern history, and fits well with what Alfred Nobel wanted. When he created the Nobel Prize, via his death in 1896, his will, written in 1895, mental note, make your will out at least a day before you die. His will said that the prize should go to a scientist who discovers or invents something that has the greatest benefit to mankind, and that was discovered in the preceding year by a single person. Again, these are rules that the modern Nobel Prize Committee ignores routinely, but yet again, see my book, Losing the Nobel Prize, for more details. This fertilizer production method is responsible for almost half of the food that we eat on Earth, and so it led to the 1918 Nobel Prizes. And it's controversial, but not for the scientific reasons that say the Bohr atomic hypothesis, shown here, is responsible for controversy. because that model is actually wrong. The atom isn't like a little tiny solar system. So although it makes predictions that are correct, the actual model on which it's based is completely wrong, as we now know. So it's different than that type of a blunder or mistake by the Nobel Prize committee.
Just a quick pause to ask you for a small favor. While my thumb is occupied with old Albert on it, yours is presumably freed up to leave a thumbs up on this video. It really helps me a lot with the good old-fashioned YouTube algorithm. Thanks a lot. Now back to the video.
Let's take a step back. We're used to talking about physics on this channel, so botany is not my strongest suit. In fact, when I would do biological experiments in high school, I would say be given a frog, I would do the dissection, but I was so bad at it, the frog would live. Plants are the backbone of all life on Earth because everything traces its energy source to a plant at some level or another. And of course, the plants trace their energy source to the sun, which we talked about. So there is a connection between what I do as an astronomer and some of these botanical delights that we're going to talk about. Plants need more than just water and carbon dioxide. They need nitrogen. Now, the air is full of it. So you might think, well, I'll just grab it from the air. That's not so easy to do. The nitrogen, in turn, forms part of the DNA structure that is so crucial to all living systems. DNA, in turn, is built from amino acids, which require nitrogen. So without nitrogen, there's no plants, there's no animal life, and we are not here to be discussing the importance of nitrogen. The role of nitrogen in chemical processes that affect botanical life is described by sources of nitrogen and sinks of nitrogen, things that replenish nitrogen and things that take away nitrogen. Denitrification, shown here, is leaching phenomena, which then produces nitrogen dioxide or nitrous oxide, or dinitrogen oxide rather, or molecular nitrogen, N2, and that then goes into the atmosphere. And the plants also suck up the nitrogen and use that to build their amino acids, which then produce the organic material that life forms like you and I will eat. Everyone out there is eating a plant at some level, even if you're not a vegetarian.
You've given me the food that my food eats.
Fertilizers can replace the nitrogen in the soil that gets sucked up by the plants, and you want to keep this process in balance. The carbon, I should say, in the amino acids comes from usually decomposing plant material that's already there. The green matter that then decays is responsible for replenishing the carbon, but it doesn't as effectively reestablish the amount of nitrogen needed for those same amino acids. So if you're growing a lot of plant life, you need a lot of nitrogen. And farming is a battle between denitrification and nitrification, so getting sources and sinks of nitrogen.
Can you farm?
They have to be in a delicate balance. Too much nitrogen can cause problems, as well as too little nitrogen will prevent the accumulation of the amino acids necessary for plant life. So this can be done in many ways. The ancient agrarian societies knew that you had to rotate crops. You couldn't keep planting the same crops in the same place and expect to get the same bountiful cornucopia harvest. Crop rotation isn't fully as efficient as actually fertilizing is, but you do have to do both of them. And of course, you can have composting, where you take manure from animals, I hate manure! Which has some nitrogen, but mostly it's carbon. It's the unprocessed food from the ruminants that don't get converted to beef or milk or whatever they're producing. And so that goes back to the soil, but again, it doesn't have as much nitrogen. It might have phosphine, phosphorus, and carbon, but it doesn't have nitrogen. Nitrogen is the key for sustaining a planet with 8 billion people on it. Population's been growing exponentially from just about 1 billion or so in Haber's time to the 8 billion number that we have today. So where are we gonna get this nitrogen from? There are sources of natural fertilizers. Fun fact, bat guano,
bat droppings,
can still be used by each and every red-blooded American citizen as a source to harvest for fertilization purposes. Look into that on your own. I don't want to be accused of even being more bat crazy than I already am. Now, air is 20% nitrogen. Let's just use that, right? No. Nitrogen triple bonds, as illustrated in this chemical equation here, is incredibly stable and very difficult to break into just single nitrogen atoms, atomic nitrogen. What about making ammonia? Well, making ammonia is very simple. You just take 2 nitrogen atoms bound together as molecular nitrogen, N2. You add 3 atomic hydrogen molecules, H2, and you get out 2 molecules of ammonia, NH3. The formula to make ammonia could be extremely simple, but the problem is it's very slow. And that's because also Ammonia is somewhat stable as well as molecular nitrogen. So this is where good old Fritz enters the story. He was a German Jewish chemist working in the 19th century and the 20th century, fixated, you might say, on producing ammonia. And for his work, eventually, and what was known as the Haber-Bosch process, he did win the 1918 Nobel Prize. What is it? How does it work? Let's do some chemistry, shall we? Haber's idea was to take the exothermic nature of making ammonia and use it to an advantage, to effectively recycle it and use the heat. The exothermic nature means it gives off heat, which you can use energy, and you have to only work on speeding it up. Once you have the right ingredients, all you must do is optimize it. At least that's what he figured. How can you get gases to react faster? It's actually a form of molecular physics. You can give them more energy, heat them up to higher temperatures. You can add in more molecules, increase the pressure. You can force the molecules to mix using shock waves to compress the gas together. And the result is that you get ammonia out of the reaction chamber. You have a certain number of these cyclical chambers, and each one processes and amplifies, if you will, the process material from the previous step. And when you have unreacted gas, as I said, it's not 100% efficient and it's also slow, you send that ammonia back into the system and start it over again. This is a self-sustaining exothermic reaction with compression at its core at high temperatures. This is the Haber-Bosch process, but not quite. What was really the key enabling catalytic ingredient was a catalyst. A catalyst is a type of material that doesn't get consumed in the reaction. You may be familiar with catalyst from your catalytic converter, which uses platinum. The main bottleneck in the reaction is separating the two nitrogen atoms in the nitrogen 2 molecule from one another so that you can make them, recycle them into NH3. Remember, you get out 2 NH3 or ammonia molecules for every 1 molecule of molecular nitrogen. So it turns out that by experimenting with different types of catalysts, mostly different types of metals, from iron to nickel, manganese, and calcium were tried, but the most effective one was a rare one called osmium. That osmium allowed him to dramatically enhance and amplify the production. And it didn't require that he use uranium, which would have probably killed him before he finished this process. The Haber-Bosch process, shown here, is used to make literally 200 million tons of ammonia every single year. Ammonia has wide-ranging uses, from fertilizers, where it uses mostly 80% of the ammonia, to explosives, to refrigerant gases, and many, many uses. The commercialization and efficient production has led to the feeding of billions of humans. Now, why is this the worst Nobel Prize in history, according to yours truly? Well, for one thing, Haber wasn't only interested in fertilization and preserving human lives. He used the fame and money that he got from this process to bolster his factories, his chemical factories. And what he was later recruited by the Axis armies during World War I, when the Axis powers were fighting the Allied powers. His chemical knowledge was used, and his chemical technology was used to create the very first chemical weapons, earning him the moniker, the father of chemical warfare. Now, this chemical warfare, you might say, well, maybe that was just, how they used to fight things back at the time, and did the US use an atomic bomb? Well, this was actually outlawed prior to World War I and signed by Germany. So Germany was party to a treaty that banned the use of chemical weapons. They were so gruesome. And by some estimates, tens of thousands of Americans and British were killed, overseen by not only Fritz Haber, but also 5 other German chemical shock troops, as they were called, all of whom had won Nobel Prizes or would go on to win Nobel Prizes. For his work, he did win the Nobel Prize, but unfortunately, the fame and financial success that he obtained was used to further sustain his chemical ambitions. And later, in World War II, Haber's family was actually killed in Nazi concentration camps that used a chemical called Zyklon B, which had been produced in factories utilizing some of Haber's own mechanisms. So his party, being a party to the Axis powers in World War I, eventually led not only to great tragedy in his family life, but to eventually devastation and destruction of his own family at the hands of the Nazi monsters in World War II. So never conflate knowledge with wisdom. As the saying goes, knowledge is knowing a tomato is a fruit, but wisdom is knowing not to put it in a fruit salad. And sometimes the consequences are far, far more grave, literally, for humanity. So never conflate knowledge with wisdom. If you'd like to learn more about the Nobel Prize and conflation of knowledge and wisdom, click here for this playlist that I made just for you.